Today's lesson is about parallel and perpendicular lines. It's Common Core 9 through 12 standard G.GPE.5. Let's first talk about parallel lines. Two lines in the same plane that no matter how far they extend do not intersect with each other are parallel. They have the same distance apart at any given point, which means their slopes are the same. So some examples of parallel lines would be these four lines. They're all parallel because their y-intercepts are different, so they're their own line, but they all have the same slope. All of them have a slope of 3. Now let's look at an example. Which pair of lines are parallel? Remember, whenever you're looking at the choices, you're looking to see if their slopes are the same and their y-intercepts are different. So if you look at our four choices given, you're going to notice that the only pair of line, the slopes are the same and the y-intercepts are different, therefore they are parallel, is B. Now let's talk a little bit about perpendicular lines. Two lines that intersect to form a 90-degree angle are perpendicular. Now, what does that tell us about their equations? Well, that means their slopes are opposite reciprocals of each other. Now, the thing about these is it really doesn't matter about their y-intercepts. They might be the same, they might be different. Only the slope matters. If the slope is opposite reciprocals, they are perpendicular lines. So what are opposite reciprocals? Well, they are multiplicative inverses with opposite signs. Or another way to say it is if you multiply them together, they will always give you -1. So let's look at an example. If I have 5, how do I find its opposite reciprocal? Well, the first thing we're going to do is change it into a fraction, which means 5, well, that's 5 over 1. Now we flip the fraction, or we do its reciprocal. So instead of writing 5 over 1, we write 1/5. The next thing we do is we change the sign. We do its opposite. It is the opposite reciprocal. So 1/5, if we change its sign, if we do its opposite, well, that's going to be negative. So the opposite reciprocal of 5 is -1/5. Let's look at a couple of other examples of opposite reciprocals. So if I start with 1/5, if I find its opposite reciprocal, in other words, I flip the fraction, I change the sign, the opposite reciprocal of 1/5 would be -5. The opposite reciprocal of -3/2 would be 2/3. And the opposite reciprocal of 1/7 would be -7. So in all of these examples, what I did was I flipped the fraction and then I did its opposite sign. So if it starts positive, the answer will be negative. If it starts negative, the answer will be positive. Now let's solve this problem. Which pair of lines are perpendicular? Remember, when we're looking at the different answers, what do we look for perpendicular lines? Well, we look to see that their slopes are opposite reciprocals. It really doesn't matter what the y-intercepts are. They could be the same, they could be different. As long as the slopes are opposite reciprocals, they are perpendicular. So in this case, the only set of lines that have opposite reciprocal slopes, and therefore is our answer, is D. Another type of question they will ask you with parallel and perpendicular lines is they'll ask you this simple question. Given a set of equations, are they parallel, perpendicular, or neither? So what you have to do is, for them to be parallel, remember, they have to have the same slope and they must have different y-intercepts. For them to be perpendicular, they must have opposite reciprocal slopes, and it really doesn't even matter what their y-intercepts are. So as we look at this first set of equations, which ones are they? Are they parallel? Are they perpendicular? Or are they neither? Well, in this case, they have opposite reciprocal slopes, so they are perpendicular. Now let's look at another example. Again, same question. Are they parallel? Are they perpendicular? Or are they neither? Well, if you look at this set of equations, you're going to look at the slopes, the value in front of x, the coefficient of x. Notice both of them are 1. And now notice their y-intercepts. They are different. So that means this set of equations is parallel. Another example would be y equals 3x plus 1 and y equals 1/3 x plus 1. Now, if you look at their slopes, you'll notice they are reciprocals. They are not opposite reciprocals. So to be perpendicular, they must be reciprocals and have different signs. Since these are only reciprocals, they are neither.